Welcome to week number 5 Supply Chain Design course. Lecture today is about production strategy that comprises some objectives as follows. First, to distinguish between push and pull supply chain. Under the pull supply chain, the process of manufacturing and supplying is driven by actual customer demand. In this type of supply chain logistics, inventory is acquired on a need basis. The benefits of this type of planning include less wastage in the case of lower demand. The problem, however, is that the company might not have enough inventory to meet rising demands due to unforeseen factors. For example, an auto repair shop that only orders parts that it needs. In this case, the business waits until it gets an order to procure the parts required for the repair. On the other hand, under push supply chain, the logistics are driven by long-term projections of customer demand. For example, at the end of the summer season, clothing brands start to manufacture more warm clothes. This type of planning becomes valuable to companies as it helps plan them for events in the future and be prepared when winter comes. This also gives the company meet their needs in time and also gives them time to figure out other logistics like where to store the inventory. The second objective is to define mass customization and modularization. There are three interrelated and complementary strategies for managing supply chain integration: mass customization, postponement, and modularization. While the goal of mass customization is to produce customized goods at low cost, postponement strategy focuses on delaying customization as close to the customers as possible. The extent of customization and postponement of products is rooted in modularization of product architecture designs. Both mass customization and postponement strategies are closely linked to modularization. Modularization is an approach for organizing complex products and process efficiently. By decomposing complex tasks into simpler portions so they can be managed independently and yet operate together as a whole. From a system perspective, modularization can be perceived as a continuum outlining the degree to which a system's components can be decomposed and recombined. In other words, modularization refers both to the tightness of coupling between components and the degree to which the rules of the system architecture enable or prohibit the mixing and matching of components. Through standardization of interfaces, modularization permits components to be produced separately or loosely coupled and use interchangeability in different configurations without compromising system integrity. Modularization enables modules or sub-assemblies that differentiate the products to be built separately from the main factory, increasing possible decoupling points in the supply chain process, hence facilitating postponement. Sub-processes can be also standardized to enable form postponement and or postponed to allocation closer to the customers to enable logistics postponements. The farther upwards the order penetration points in the supply chain, the higher the possible degree of customization. The ultimate order penetration point is when the design process does not start until the customer order is received. Examples include large construction projects such as bridges, ships, and nuclear power plants. Now we finally go to customer order decoupling point or order penetration point. Order penetration point or customer order decoupling point or CODP is traditionally defined as the point in the value chain for a product where the product is linked to a specific customer order. Sometimes the CODP is called the order penetration point. Different manufacturing situations such as make to stock or MTS, assemble to order or ATO, make to order or MTO, and engineer to order or ETO are those all relate to different positions in the CODP. The CODP thus divides the operation stages that are forecast driven upstream of the CODP from those that are customer order driven, the CODP, and downstream. The CODP is also the last point at which inventory is held. Thus, the inventory at CODP is a strategic stock point, since delivery promises are based on the stock availability at the CODP, and the lead times and capacity availability for the customer order-driven activities downstream of the CODP. Let's go to our case study about production strategy at Dell and Lenovo. The first case company is Dell. Dell is well known for its direct sales model and its ATO or assemble to order approach. This means manufacturing and delivering individual PCs configured to a particular customer specifications. Instead of pre-assembling a complete PC, Michael Dell created a supply chain where inventory of components is held in a few centralized locations. And as customers placed their orders, a Dell computer would be assembled exactly to the customer's requirements. This was Dell's customized approach. Dell eliminated markups charged by dealers and vastly reduces the risk of carrying large inventories by taking orders directly from the customers and building computers with the specific options individual customers wanted. Dell implemented this strategy through a combination of outsourcing and mass customization. Dell does not manufacture the semiconductor chips used in its computers and does not attach the chips to the computer motherboards. Instead, it buys computer motherboards from suppliers. Since Dell suppliers are mostly from Far East, such as Japan for RAM chips, Taiwan for monitors, and Singapore for disk drives, Dell asked Airborne Express or UPS to pick up all those components and modules from suppliers to its plant in Texas. Technicians who service Dell computers in this field are actually employees of other firms operating under contract with Dell. Major customers such as MCI can access information directly through the web. While using the ATO strategy or assemble to order, cycle times are reduced and inventory expenses are kept at a low level, as not all varieties of products needs to be stored but only the standardized versions. Also, the assembly is quite easy because the features that can be chosen are rather independent from the outer appearance of the device. So after all, Dell can offer high quality products at comparatively low prices. The improvement of Dell delivery service level are as follows. The lead times for shipping to the customer was initially from 4 to 6 weeks. With the ATO model, a PC could be fully assembled in 1 to 2 days and the customer receives the order by the end of the week. This significantly reduces the inventory holding cost incurred during shipping as well as improves customer satisfaction. With this strategy, Dell commonly holds inventory for less than 4 days. By using a postponement assembly strategy, Dell is able to generate cash much faster and reinvest this cash into improving their supply chain model. The above strategy enables Dell uses online channel that has proven very effective for the sale of computer hardware, and by 2009 represented about half of the sales in this category. The online channel also provides hotlines and live chat with sales representatives of their website as a sales expert during purchasing process. In 2007, Dell expanded its sales channels and started to sell PCs through retail stores. In terms of sourcing strategy, Dell created a network within its factory that made it possible to select one of many possible configurations and load it efficiently. The internal processes that make this mass customization approach possible start with estimates of demand with component suppliers. Dell maintains electronic links to its suppliers that tell them exactly when parts are needed. These electronic links help make sure that Dell uses one of the most current parts and does not have to store large inventories. Dell tracks its inventory velocity and reduces its inventory risk to 11 days, meaning that its risk of holding obsolete inventory is minimal. When its inventory balance is not quite right, it can use its direct sales model to steer customers towards products that can be built with available inventory. Analyzing Dell's business model, we found that the ideas behind Dell's business are not new. Dell's effectively integrating this idea into a work system that is highly innovative, efficient, and effective. That is the key for Dell's success. The idea of virtual integration is realized by aggressively extending the value chain to its customers and suppliers to a level that virtually blurring the boundaries of organizations and forming a virtual value chain, or what we call virtual integrations. We can compare with vertical integrations or physical integrations. We consider that this is one of the critical success factors for their computer. In the context of mass customization, computer manufacturer, Dell is often named as the most successful model of mass customization. However, this company managed neither to lower the cost of its mass customization production, nor to make its production processes flexible enough for the mass customization. Dell utilized a single direct configure to order CTO model and gave its customers a cascade of options to choose from when configuring a product specifically for their needs. Although mentioned by Dell representatives as a good model for mass customization, it has been too complex and costly for the company to maintain. Company also stated that configuration process is economically only with premium prices of products. We can just assume that the company could not achieve the robust process design and suitable solution space as a key for mass customization capabilities. Also, the influence of economic crisis on Dell's living out mass customization strategy. Therefore, Dell's need to revise its strategy. The model was mainly meant to be for mass production of personal computers for business customers. However, nowadays, most sales are generated by laptops for end customers. Now let's move to Lenovo. In our textbook, Lenovo is described as a global company that established in accordance with functional, geographic, and internal customers dimension. In order to increase customer service in major markets, Lenovo established strongholds in Europe, America, Singapore, and Shenzhen in China to provide customers with business and financial services. Lenovo supply chain includes raw material procurement, production at 3 locations in China: Beijing, Shanghai, and Huyang. Also includes product distributions, transportations, warehousing, including outsourcing, and payment. Lenovo inventory cycle is now within 10 days. The cash cycle can be achieved within 10 to 20 days. These performance indicators actually contribute to relatively high profits for Lenovo in China. In 2005, Lenovo sets product development and marketing in Hong Kong. This strategy actually enables Lenovo's technical staff to receive timely market and technical information and to understand the progress of markets and technical aspects. This also shortens the company product's development cycle, and the company products can keep up with international trends. Considering the labor cost and price of real estate in China, mainland China, are much lower than in Hong Kong, Lenovo is able to reduce manufacturing costs and at the same time build outsourcing strategy by developing cooperation with other domestic manufacturers in Shenzhen and other places in China. In addition, it is not difficult to get raw materials such as monitor, hard drives, video cards, and even the chassis and other parts that is typically organized in collaborations with suppliers in Taiwan. And Taiwan is one of the world's supply centers for IT components and near to mainland China. Finally, the company has more than 5,000 customer channels in China that makes transportation of orders are much cheaper than producing outside China. In production and in inventory management, Lenovo takes a combination of make to stocks or MTS with a large margin of safety and make to order or MTO with a relatively low safety stock of finished goods to cover demand for only a couple of days. In mainland China, Lenovo suppliers operate warehouses near Shanghai, Beijing, and Huyang, so that these 3 factories in those 3 cities can be delivered faster. Recently, Lenovo has opened production facilities in the United States to improve the relationships with its business customers and to be able to offer more flexible support. Lenovo also employs VMI strategy in vendor-managed inventory and is supported by third-party logistic partners BX Global Freight Logistics Limited that is responsible for inventory control. The third-party logistic company is responsible for replenishing the production line at the right time with right items at the right quantity. VMI relies on sharing information between suppliers, third-party logistics, and Lenovo ensures timely delivery of materials needed for production. As a result of implementing VMI, Lenovo streamlines its internal business processes and make better demand response and higher inventory turnover. The support of IT systems enable Lenovo to monitor visually its inventory level that generate cost reduction and supply chain flexibility. VMI also improves supply chain integration with timely information sharing and precise and efficient integrations of operations. Lenovo distribution channels are distributors, agents, distributors of contract, and distributors of non-contract. Lenovo subdivides functions of different channels and uses two channel systems. One channel for home computer delivery and one channel for business computers delivery. The differentiation of distribution channel harmonized Lenovo and its logistic partner business relationships by minimizing competition among those logistics operators. The differentiation also enables Lenovo to shorten its supply chain that flattens the structure of its distribution channel. For make-to-order production, direct shipments are organized. As retail products, customers are able to order Lenovo's products online, but without any adaptation tailored to customers, meaning that Lenovo only available for standard order. To manage the complexity of the supply chain, Lenovo uses an ERP systems or Enterprise Resource Planning from SAP. ERP helps Lenovo to run an effective supply chain execution by monitoring huge supply chain data in real time for more accurate information, helping to enable fast decision making in order to facilitate a responsive supply chain and improving logistic efficiency. It also provides end-to-end visibility of the entire global supply chain and increases transparency and efficiency with real-time access across the supply chain. Now let's move to push-pull view. The push or pull view of the supply chain divides supply chain processes into two categories based on whether they are executed in response to customer order or downstream part or in anticipation of customer orders or make to stock in the upstream part. Pull processes are initiated in response to a customer order. The advantages of the downstream part are responsiveness and high degree of customer-oriented product individualization. Push processes are initiated and performed in anticipation of customer orders. The advantages of the upstream part are the economy of scale, low manufacturing and transportation cost, flexibility with high level of inventory, and the short supply times. This view is very useful when considering strategic decisions relating to supply chain design because it forces a more global consideration of supply chain processes as they relate to the customer. The push and pull supply chains have been studied in a variety of settings. In a push supply chain, the retailer pre-books the inventory from the supplier before the selling season and takes all inventory risk. The supplier charges a single wholesale price upfront and will not accept at once order in the selling season. Push supply chains have been widely seen in practice as channel stuffing or supplier selling to a new vendor. In a pull supply chain, the retailer only places at once orders in the selling season, and the suppliers manage the inventory and takes all inventory risk. Pull supply chains are exemplified by retailer buying from a new vendor, vendor managed inventory, consignment inventory, and drop shipping. The different allocation of inventory risk in push and pull affects a supply chain's performance. It shows that the optimal order quantity is higher in pull than in push. As a result, pull achieves higher supply chain efficiency than that of push. In the pull Pareto set, a pull contract can survive push challenge because the retailer has no incentive to pre-order inventory before the selling season. All these results are based on the assumption that both the supplier and the retailer are risk neutral. Now we go to production strategy. In order to compete successfully, operations in any type of firm need to be strategically aligned to the market requirements. The motivation of this idea is that companies are showing increasing interest in incorporating the customer order decoupling point, or CODP, as an important input to the strategic design of manufacturing operations as well as supply chains. The CODP is the point in the material flow where the product is tied to a specific customer order. The basic choices being make to stock, assemble to order, make to order, and engineer to order. As a rule, the CODP coincides with the most important stock point from where the customer order process starts. From a supply chain perspective, there is a typically one dominant CODP along the entire supply chain flow. From a company perspective, the CODP can be positioned inside their manufacturing operations, or it can be positioned at the suppliers, first tier, or even further upstream in the supply chain. At the interface with the supplier, for instance raw material inventory, at the border towards the customers at some finished good inventory, or even further downstream in the supply chain. The CODP is traditionally defined as the point in the value chain for a product where the product is linked to a specific customer order. Sometimes CODP is called order penetration point. Different manufacturing situations such as make to stock or MTS, assemble to order or ATO, make to order MTO, and engineer to order ATO are related to different positions of CODP. The different situations are related to the ability of manufacturing operations to accommodate product customization or a wide product range. Thereby, in our figure, the CODP divides the material flows, that is forecast driven upstream of the CODP, from the flow that is customer order driven downstream of the CODP. The CODP is the point where product specification get frozen in most cases, and more important, it is the last point at which inventory is held. Thus, the inventory at CODP is a strategic stock point, since delivery promises are based on the stock availability at the CODP and the lead times and capacity availability for the customer order driven operations downstream the CODP. The literature explicitly discussing the CODP is growing, dealing with both manufacturing and supply chain operations. The CODP is considered as a major factor in designing an integrated push and pull manufacturing strategy. There is a strong consensus among literature on CODP in that the operations upstream are significantly different than those downstream, based on the fact that the upstream material flow is forecast driven, where the real customer orders dominate downstreams. The model that we see in our slides links market characteristic to the design. Okay, now we move to order penetration point and postponement. Even though Van Hook in 2001 defines postponement as an organizational concept whereby some of the activities in the supply chains are not performed until customer orders are received, the concept of postponement has a long history of practical applications, as well as academic literature. Practical applications of the concept can be traced back to 1920s. The first detailed empirical description appeared in the 1960s. In the literature, the concept was originally proposed by Alderson in 1950 and later expanded by Bocklin. The logic behind postponement is that risk and uncertainty costs are tied to the differentiation, and there are three types of differentiation: product forms differentiation, place differentiation, and time differentiation. And those differentiations occurs during manufacturing and logistic operations. To the extent that parts of the manufacturing and logistic operation can be postponed until final customer commitments have been obtained, the risk and uncertainty of those operations can be reduced or fully eliminated. The notion of manufacturing postponement is to retain the product in a neutral and non-committed status as long as possible in the manufacturing process. This means to postpone differentiation of formed and identify to the latest possible point. The notion of logistic postponement is to maintain a full line of anticipatory inventory at one or a few strategic locations. This means to postpone changes in inventory location downstream in the supply chain to the latest possible point. So two key and very well-known contributions to the concept of postponement are to the result by Cooper and Sin and Bowersock. Cooper identifies four different supply chain postponement strategies for global brands. These are the bundled manufacturing strategy, the unicentric strategy, the deferred assembly strategy, and the deferred packing strategy. In the key work of Sin and Bowersock, 5 different types of postponement strategies are identified. 4 different strategies of form postponement includes labeling, packaging, assembly, and manufacturing, which, when combined with time postponement, constitute the 5 postponement strategies. In general, postponement is useful for significant number of variants of an end product with an uncertain split of demand on variants. Meaning that if we have a lot of variety of products to be offered to our customer, we do not want to keep inventory of each of those variants on hand, and therefore it is more safe for us to keep the generic product before making customization. And also for delivery time requested by customers must allow value-adding steps after receipt of customer order or reliable demand forecast. Meaning that postponement strategy give opportunity for a company or a manufacturing company to make customization at the closest point of customer order. In this slide, manufacturing postponement, whether it is light manufacturing, final assembly, packaging, or labeling, are performed at some point downstream in the supply chain, after the product to some degree has been logistically differentiated. Furthermore, these final operations are deferred until a customer order has been received. Where the retailer or customer order point is positioned prior to the final manufacturing operations, the first stages of the manufacturing process are centralized and inventory initiated. This strategy could also be named the post-factory manufacturing strategy. Full anticipatory logistics are applied, since products and/or components are distributed and stocked throughout a decentralized distribution system in anticipation of future customer orders. On the first, or one of the first, and now classic examples of this strategy, that is manufacturing postponement, was to postpone the color of paint to the retailer or customer level. Rather than holding a wide variety of premixed colors, retailers began to stock paint in a natural color and customize the final color upon specific customer orders. This of course dramatically reduced the retailer's number of necessary stock keeping unit or SKU. Thus, this allowed keeping safety stock of one generic product instead of multiple specific end products. Therefore, a risk of obsolescence of end products, in this case the color of paint, can be minimized due to the postponement strategy can eliminate the uncertainty of split demand into specific end products. Furthermore, as less value has been added to the generic product than to the specific end product, less capital is bound in its stock unit. Another example is Hewlett-Packard's employment of decentralized final customization of their DeskJet printers for the European and Asian markets. Instead of customizing the DeskJet printers at the factory, HP decided to postpone the final manufacturing operations for power supplies, packaging, and manuals until the local distribution centers. It is now only necessary to manufacture, distribute, and stock at the local distribution centers one kind of DeskJet printer. The final customization at the local distribution centers is now based on customer orders. As a result of the decentralization of the final manufacturing operations, manufacturing cost has increased slightly, but the number of SKU or stock keeping units and the safety stock have dropped. Furthermore, the total manufacturing, shipping, and inventory costs were reduced by 25%. The manufacturing postponement strategy can be successfully applied when it is vital to have inventory close to customers, and to the extent that no specialized manufacturing capabilities, for instance technological or knowledge-based or highly restrictive economies of scale, requires that the operations are performed centrally. The impacts of employing this strategy are several. The variety of differentiated products moved and stocked in anticipation of sale can be reduced, while providing a full assortment. Further, the effect is a reduced total value of inventory and a simplification of the inventory planning and management. On the other hand, the cost and complexity of customer order processing most likely will increase. For the manufacturing operations performed downstream in the supply chain, economies of scale will be reduced, as in the HP DeskJet case. Logistic economy of scale will most likely not change much. In this slide, a figure of all the penetration point separates push processes from pull processes, signifies a boundary between certainty and uncertainty of demand. In order to reduce the demand uncertainty, a product is kept as long as possible in a generic state, and product customization is delayed as close as possible to the customer. The area where uncertainty exists, agile supply chain is needed, while the area where certainty exists, lean supply chain is needed. Thus, the figure shows the coordination between push and pull strategy, between lean and agile supply chain. In a case of a customer inquiry or order, the goods can be delivered from a general inventory holding unit without customization or standard product. We follow trajectory alpha. Otherwise, customize products according to the inquiry of order trajectory beta. Okay, this is our course for part 1, week number 5. See you on the part 2, week number 5.